Okay, so we can start. So I'd like to welcome you all to today's lecture in ReForm format, and I'm especially happy to welcome María Florencia Becerra, which we call María, but her true first name is Florencia, so we switch all the time. Okay. Dr. Becerra is scientist at the CONICET, the National Council of
Scientific and Technical Research
of Argentina, and at the same time the National University de La Plata in Argentina. She came first to us in 23 when she had a Georg Forster Humboldt stipend, and she came here for 9 months, bringing her complete family with her, the little girls and her husband. And she spent 9 months with us, and we were just learning from each other. And she started to, set up the basic archaeometallurgy for her country and for the north of Argentina. And so she spent that time here at Deutsches Bergbaumuseum at the archaeometallurgy section. So, and then after this it developed, and Humboldt has a good sort of programming so that she could apply for a continuation of a return fellowship. So that's also the second thing. And the third was a project which we just started with in October last year. And it is a Humboldt linkage program, which is especially there for linking different institutions from different countries. So we are linked now through that project, and it is for 3 years of a run. And the project has a concept like María comes here for 3 months this year, and followed by Matthias Joaquin Dalto, who is with us here in the online audience. Welcome. Welcome to all of you. And he will come in March for 2 months. And in the next year, we do the other way around. So the group of the Bochum archaeometallurgy will go to Argentina and sort of doing the same, exchange knowledge, hold lectures, and so on. So the group is basically consisting of Dr. Becerra, who is the main leader of the project, and her group in Argentina, which is Matthias Dalto and Marianela Toballo. And at the German side, we are 3 people basically who are involved. This is Dr. Katrin Westner and Thomas Rose, who just left us and went to MIT and started a new position there, but he is still active in the project. So we have, I guess, a good exchange during the next 3 years, and we are really looking forward to that. Dr. Becerra will now introduce you to her research topics, and so you will see it. So we have a series of lectures, 2 lectures and 1 workshop, and the next lecture is next week, and then the workshop is on the 28th. Yes. So you're very welcome to join all the lectures and the workshop as well. I asked for registration for the workshop, but it's only to have a head count for participation, so don't worry about sending me an email. So if you like to participate, you can still register for the workshop as well. You do not need to register for the lectures here. So, what else? Yeah. For the students, we have a list here. So if you need to sign in for your participation today for the CPs, please do so. The list is here in front on the desk. So don't forget to sign in. María, the floor is yours.
Thank you. Thank you very much to all for coming. Thank you, the ones that are connected online. Well, I'm sorry I speak in English for you. I should have spoken auf Deutsch. but well, it's good for the ones connected that I speak in better English than German. So, well, today, as Sabine said, it's the first of this series of lectures that are framed in this linkage program that we have going on with Sabine and her group, linking Bochum and the Museo de la Plata. But I wanted to say that, as Sabine said, I am an archaeologist, I am a researcher in the National Council of Research in Argentina, but as any scientist, and especially archaeologist, I don't work, sorry, I cannot, cannot change here. I don't work alone. I work in a team, and this team is, even though I'm based in the Museo de la Plata, near Buenos Aires, the capital of Argentina, I work with people from the northwestern of Argentina, in Tucumán especially, and we have been a group of archaeologists and historians from the North Puna in Jujuy, Argentina, led by Carlos Angiorama. We have been working for more than 20 years now in that region with Josefina Pérez Pieroni, Marcos Justa, Silvina Rodríguez Curleto, Lucrecia Torres Vega, Mirela Lauricela, Valeria Franco Salvi, and other students and researchers. And I wanted to say this because part of the research is framed in this project with these people, and is the product of the fieldwork we have been doing for more than 20 years in the region. And as Sabine said already, I've been here for 9 months in 2023, thanks to a Georg Forster Forschung Stipendium, and it was the aim of this fellowship was to start studying provenance and circulation of copper during pre-Columbian times in the northwest of Argentina, and performing the first lead isotope and trace element analysis on archaeological samples from the northwest of Argentina. And since October, we have this research group linkage program, and well, this is, as Sabine said, it's the collaborative partner is from Bochum is her, and it's Kathleen Besner and Thomas Rose are joining this project, and from the Museo de la Plata, myself and Matías Alto and Marianela Taboada. And the title is Weaving Knowledge, Copper Provenance and Circulation in the Pre-Columbian Southern Andes through Collaborative Approaches and Exchange between Germany and Argentina. So here, for those who are not so familiar with the Andes, I am going to talk about this region, and especially the region that is in this southern part of the Andes, that is the north of Chile, the northwest of Argentina, and the south of Bolivia. And what you may know is that this area is very rich in copper deposits, as Andreas Hauptmann has already made this graphic, and it's also rich in other minerals that were used during pre-Columbian times, as arsenic, nickel, and tin. As Lechman said, from the north of Ecuador to all the north of Chile and northwest of Argentina, we have copper-rich and arsenic-rich deposits, and the tin is located in the south of Bolivia and extreme north of Argentina, and also in the center of the northwest of Argentina. And as you may see, there are other deposits, silver and gold deposits, that were exploited during pre-Columbian times, but metallurgical tradition of Andean metallurgical tradition was based mainly in copper and its copper alloys. So what we see is that there is evidence of the extraction of copper in some areas of this of the Andes. The most well-known areas are in the north of Chile, the ones that were most studied by researchers there, as you can see here, where they could record the evidence of exploitation of copper, the tools they were using. At least the most evident ones are from 1,000 years after Christ and on, but there are indirect evidence of exploitation of copper way before that. And well, the team of Stirner here in the south of Peru, he has also recorded evidence of copper exploitation in the area of Nazca, and in the northwest of Argentina we are looking and trying to find evidences of these mining operations. But what they were using the copper for? On one hand, metallurgy, I have already said that Andean metallurgical tradition was based in copper. There were a lot of different objects that were made in copper and their copper alloys, like arsenic copper, tin bronze, copper antimony, copper lead. But this is something we will talk in the next lecture, so I won't be talking about metallurgy now. Other use of copper was for pigments. So, for example, these leather artifacts or the rock art in the north of Chile were made with some chlorides and sulfates of copper, like atacamite or brochantite. And what I'm going to talk about now is the lapidary industry. So copper was used for incrustations like this to these objects, wooden objects, and also and mainly for manufacturing beads, as you can see here in this slide. And these beads are mainly found in funerary context, but also they are found in residential context and in other different contexts that I would like to talk about here, and they are linked to ritual practices and linked to long-distance trade interactions and caravan movements especially in the late period, what we would call the 1,000 year more or less before after Christ, to the Spaniard conquest in the region. So, to understand why this context of long distance trade, we have to understand that the Andes have different ecozones in a very short distance. You can find different ecozones that people in the past used it and moved between because they needed to make use of the different resources that each ecozone had. In the case of this part of the southern Andes, as I said, the north of Chile, northwest of Argentina, and south of Bolivia, it's the same as Central Andes, but it's more arid, it's more dry, it's more cold, it's colder, and it also has less areas of production. So we have a very wide area that we call the Puna of High Plateau, that it was used especially for llama herding. And this, despite all the difficulties that this kind of landscape had for ancient populations, we can see in the archaeological record that the different resources that each of these ecozones had were moving. So we can find in the lowlands obsidian that belong to the high plateau area, and we can find in the high plateau area feathers like these tropical birds' feathers that belong to the lowlands. And this was explained by the movement of people, by some relationship and kinships, but also for pastoral transhumance, but especially through the caravan movement of goods and people. And this long-distance trade through caravan had one resource that was had a very relevant role, that it was the copper. So copper was is thought to be part of the load, part of the goods that llama herders take from the areas rich in copper that are the desert or the high plateau to bring it to other areas where these ores are not available. But also they have been thought as part of the caravan equipment, as part of things that these llama herders take with them to do some ritual gestures and practices, and also as part of their own identity. And before going on with this, it is important to understand that that Andean inhabitants in the past and also in the present share this cosmology of animism. They believe that world is inhabited by humans, but also by very powerful agents that are not human, but they have intentional actions that can explain what we as Western or modern people would explain as as due to natural mechanism or physics. So to go on with their lives, they have to interact with these non-human agents, because they are the rocks, they are the hills, they are these mountains that have the copper mineral, and they can give it to the miners, but they can also take them away. So they have in every, and especially when they are traveling long distance in this very difficult environment, they have to do some payments, some offerings, some asking for permission and some asking for protection in these different points in the landscape. So copper is part of these ritual gestures and practices to this interaction with non-human agents. But it is part as beads, it's part as possible as the metals, but it also participates like crushed and ground minerals. So different scholars like José Berenguer from Chile, Lautaro Núñez, also for Chile, or Axel Nielsen, have shown how these crushed minerals, these green copper minerals, are found in certain sites that are linked to, for example, the caravan campament sites, these wall and boxes, muros y cajas, wall and boxes sites, where apart from feathers from tropical birds, part of llama skeletons, and some pottery from different regions, they find crushed copper and copper beads. And as you can see, and this is thanks to Valentina Figueroa, some of the sites are covered almost completely with these crushed green minerals. And these sites in general are located in a place oriented to some important hills in this landscape. And these offerings are also found in near water springs, and also in funerary offerings like this. This is from Salta in northwestern Argentina, and this is from the Puna of Jujuy, where I work, where you can find these crushed minerals inside some leather bags. They have been interpreted as part of these propitiatory rituals and fertility also rituals, but also linked as part of this equipment that the caravan herder took also in the afterlife, no? As part of this funerary offering. And these crushed minerals are also in these places that we call the abras or mountain passes, that are places that in general are more dangerous, are the places where some paths change their orientation, and these places have in general nowadays these kind of mountains of rocks or apachetas that are full of offerings that people who goes there offer for to have a good trip. And also they are found at the top of low mountains, but they are important for the local population. And that's the context we will talk about, especially in this presentation. So for caravan campament sites, Axel Nielsen has established that mostly all of the campament sites for caravans that he has recorded are in the south of Bolivia, in the area of the triple frontier between south of Bolivia, north of Chile, and northwest of Argentina, have crushed minerals, and these are chlorides and carbonates. And he has linked these copper minerals to the ore deposits in Chile. And recently some lead isotopes analysis he performed on 2 samples show also a very similar signature of these copper ores to the ones in Chile. So this is part of the load or the equipment that these caravan herders are bringing from Chile to other parts. But he also has studied these mountain passes, these abras, and what he sees that there are offering pits. There are sometimes holes or sometimes some rock structures that have always different offerings like ceramic, like white stone, but all of them, as you can see, have these green fragments of crushed mineral and sometimes beads. And in general, the beads are fragmented. So what am I going to talk? It's our own research and our archaeometric analysis of the offering pits, of the material found in the offering pits in the area I work with the archaeological team I have mentioned in the north of, in the extreme north of Argentina. That it's an area, it's part of this high plateau, it's above 3,000 meters above sea level, and it's a very plain area, very high plain area that has some hills, low mountain hills, and that in the past, especially during the late period, that it's 1,000 years after Christ, they have a dense conglomerates with dense population. Here, for example, at the up in this defensive area of the Pucará of Rinconada, but also in this part as it shows in Moreta, in this site. And these conglomerates are linked, are associated with agriculture and also pastoralism. In this area, we have also record rock art linked to these motifs of caravana herders and the llama caravans. So in this area, we have found 10 offering pits that are 2 are linked with these mountain passes that we very similar to the ones that Axel Nielsen worked, and this is Ajedrez 2 and Abra Cabalonga, but other 8 that are linked to these mountain hills like this. So we have this very high plain area, this high plateau with these hills that are very, very visible in the landscape, and in this top we have found offering pits. And I put this part of this document from the 17th century because it says that one leader, indigenous leader at that time, in the middle of the 17th century, is punished for the Spaniard because he continues to go to worship the idols, the ancient idols in the mountains, in the hills. So these offering pits look like this. This is one of them. This is Cerro Pan de Azúcar. This is one of the structures that are in the top. And you can find, again, the green minerals, the crushed green mineral, these debris, the beads, green and white, especially volcanic ash. So, what we have done so far. Okay, we have 10 of these offering pits that have the green minerals, the green bluish beads, the white beads, and some of them have pottery and other materials as obsidian or quartz or basalt or other, or even plastic for later moments. So, what we see is that, as I have told, most of them have green mineral crush, except from Pan de Azúcar 29 that only has beads. But what is also important that in general, as it was mentioned also by Axel Nielsen and collaborators, the green beads are in generally fragmented, they are broken. But it's not that they are broken and you can find the other half, or they are just half of them or quarter or whatever. But in general, they are fragmented. And only in Abra Cabalonga and Cerro Pan de Azúcar and Cerro Chiquito, in 3 of the 10, we find completed beads. In general, the beads have different colors. They are bluish-green, but have different colors and have different shapes. But in general, they are this disc shape, and we can find some tubular ones. What we have done is to choose a sample of these, the green minerals and the bluish-green beads, and also some white beads to make mineral identification, because we wanted to know what kind of minerals were and if we could say something about provenance or about what they were choosing for doing these offerings. We also made, we only choose 6 of the 26 white beads, and well, they were not related with copper, but we wanted to know what they were, because in general the others are clearly volcanic ash, toba volcanica, but these were different, so we wanted to know what they were. And in the case of the green minerals, we made a selection of almost a quarter of the sample, the total sample. And in the case of the beads, we analyzed almost all of them. We used different techniques. We wanted to compare some of the techniques because for our previous work, we know that they are useful if you complement at least 2 of them for mineral identification. We have used portable X-ray fluorescence for elemental composition, for a very quick elemental composition analysis, but that it was helpful to know at least what compatibilities of different minerals we were talking about, if it had copper or not, if it had, for example, aluminum or phosphate, we could say, okay, this could be turquoise or not, thinking of the ideal formula for the minerals. And then we use Fourier transform infrared spectroscopy, Raman spectroscopy, and in some cases X-ray diffraction. And of course, this would not have been possible without the help of the collaboration of people in the lab as Elena Gomez Sanchez that is here, and it was all this research was possible during my stay here in 2023, and the help of Marion Jung and Till Gent, who did also, Marion worked with the Rahmen and Till with XRD, and also people in Argentina who helped me continue some of the samples that were not possible to analyze here. And how did we work? We knew that we couldn't run all the analysis for all the samples, so we tried to have a corpus of samples that were analyzed at least by the 3 techniques, like these 12 samples that were analyzed by portable XRF, FTIR, and Rahmen. And then we have some that were analyzed by infrared and portable XRF. And then these others that were analyzed only by one of the techniques, but with a comparison with the more than 60 samples here, we could say that this is a good identification of the minerals. So the results. This, the white beads that I have talking about this were identified as heulandite, that it's a luminosilicate with formula that is quite variable, and it has several groups. Some of them are rich in barium, some of them calcium, potassium, sodium, or strontium. It's apparently non-local. Its geological database said that they come from Lipes, from the south of Bolivia, but we are not sure that Puna of Jujuy, this area, has or not deposits, because we believe that they are not economically important, so we don't know if the geologists said that they are not really, or they have not recorded yet, so that's something we have to think in the future. And we see that the beads are one from made of sodalite, the others of turquoise. So we have this very clear pattern that almost all the beads are made of turquoise. And we have a bigger variety regarding the crushed minerals. We have turquoise, we have brochantite, we have atacamite, we have chrysocolla, malachite, and even non-copper bearing minerals, but they are green, but they are quartz or opal. So this is more or less the summary of the results. And what we can see is that even though Pan de Azúcar is the place where the more quantity of crushed minerals and beads were found, Cerro Chiquito 10, it's the one that has all the variety in a very small scale. It has 2 of each and 1, but it has all the minerals in the same place. And and in the case of the turquoise, we only have debris of turquoise in 4 of the 10 offering pits. But in the case we have, the turquoise is very small. We don't find very big pieces of turquoise. In fact, they look more like little debris that were like there is the product of the manufacturing of the beads, or maybe a very little piece of a broken bead, but not the turquoise as a big piece. As you can see here, they are very small. So after these results, we wonder, okay, what's happening with the minerals that are found in other contexts that are not these offering pits? So we have other contexts here, the red ones, that are very, very different from each other, very different from the offering pits, and they are, some of them are colonial mining town or pre-Columbian and colonial mining settlements. All we have settlements and pre-Columbian settlements, the ones I showed you before, Pucara Rinconada, Moreta, and different sites with different scales that have some green minerals and bluish green beads. So we wanted to know, okay, this is different, no? And we follow the same protocol. In this case, we added in 3 samples. We made analysis by XRD, and we see that all the beads, the 11 beads, are made of turquoise. There is no doubt of that. They are almost all completed. They are different from the offering beads that were, most of them were fragmented. These are almost all completed, and they have different shapes. They have this, we have found this rectangular shape that it's not common in the offering beads. We have not found this kind of bead there. And there is no evidence of this little debris or anything as crushed mineral of turquoise. So we have not found any evidence of turquoise manufacturing beads in any other site in the Puna Jujuy. We have found this kind of manufacturing evidence, but of these volcanic ash beads, but no for turquoise. And about the crushed green minerals that we have found in these other sites, they are malachite and brochantite. They are the diversity of minerals found in these sites is very low comparing with the offering sites. So, what does these results tell us about the ores used, the minerals used, and the provenance? We have this sodalite. It's only one. In the literature, we found that there have been 2 or 3 more beads of sodalite found in sites that were not offering site, but they were funerary contexts in the area. This is a sodium-rich aluminosilicate, and it is the sources are not so much, and in general, it is thought that they come from this area in Cochabamba Valley in Bolivia, that is around 60 kilometers far from the area we are working. That it's not this red one, this is another work, but it's here. So we have this Cerro Sapo ore deposit for sodalite that is 600 kilometers away from this area. And about the turquoise, we know that there's a the beads are predominantly turquoise, made of turquoise. 63 out of 65 are made of that for offering beads, and 11 from 11 are in these other sites we analyze. There's a great variability of colors. This turquoise is a secondary mineral, so we understand that it's changing and this weathering process that, it has, and the changing in copper content with iron content can make these changes, but that is what makes identification macroscopically very difficult, because we cannot say which is turquoise and which not. And it also has some presence of iron minerals as goethite, hematite in some of the samples. And what we have also seen performing infrared spectroscopy is that many of these turquoise have a lot of clay in it due to this the origin process. So sometimes the infrared makes the identification as clay, but it is turquoise. So this is something it is useful for the ones who are trying to identify turquoise through infrared. And what about the sources of the turquoise? There are more than the ones for sodalite. They are located in the south of Peru, in the north of Chile. Traditionally, any finding of turquoise in the northwest of Argentina was directly linked to north of Chile, but since 2017, and that this turquoise mine was found in the northwest of Argentina by Gabriel Lopez and his team, we see that there is evidence of pre-Columbian mining of turquoise in the northwest of Argentina. So this is another area that can be providing turquoise to this part of the northwest of Argentina. And what we see is that potentially and very possible, the arrival of the turquoise is as finished objects, as finished beads, and they are not manufacturing beads here. And all these sources are about 300 to 500 kilometers away from these offering sites we are studying. Regarding the other crushed minerals we have identified, we have atacamite, that is a chloride that is present in some desertic environments. In general, it was also linked very directly to Chilean mines, but new studies that we have performed in other mines showed that there is atacamite in the northwest of Argentina, but it's also far from the Puna Jujuy, this area we are working. In the area, we can find malachite, we can find brochantite, and also chrysocolla, but it's very difficult to, at least for now, to know, to do a more specific identification of the ore deposits they come from. So finally, what do these archaeometrical identification tell us about the provenance, use, and circulation of copper minerals during late pre-Columbian times in this region, and about the choices, long distance, and ritual practices of the Puna Jujuy inhabitants they were involved in? So, what we can say is that local population access to non-local minerals and finished objects as the turquoise beads, potentially coming from northern Chile or the Puna of Salta, from 300 to 500 kilometers away. However, as I said, provenance identification remains still too broad. Valentina Figueroa, Pia Sapiens from north of Chile are trying to understand the difference between the different mines of turquoise and chrysocolla that they have in the north of Chile. We have to do the same in this part of the Andes, but we need to have a comparison and try to figure out how to go deeper in this classification and identification of different sources. We can see that turquoise is used in a long sequence, chronological sequence, spanning at least from 1000 AD to the colonial period. And the beads, as I said, are predominantly made of turquoise, as in other contexts of northwestern Argentina. We have studied different areas, and in general, turquoise beads are predominant. And bead shapes are less diverse in the offering context than in other contexts, as these rectangular shapes that are not appearing in the offering beads. What we said was we have already seen is that different minerals are present in different types of sites, although the variability we find in the offering pits is higher than in contexts that are not these offerings. And these offerings are comparable, are very similar to the ones associated with long-distance caravan trade in these neighboring regions, as studied by Nielsen and his team, but in this case they are mainly linked to local mountain tops. So what we are saying is that they are local ritual practices that involve, as in the others, local resources like volcanic ash, that they are making the beads in the same sites, probably these known copper-bearing minerals, or maybe this malachite, we don't know, and non-local resources as the turquoise, the atacamite, maybe the brochantite, and the obsidian, and other minerals. As in other cases in literature, what we see is that the green-bluish color, the copper, means it's important, but at least the color is at least equally significant that the copper content, as it is suggested by the presence of this green quartz or opal mixed in the offering pits with the mineral copper. So what it really matters is the color in some cases. And these hills have been very relevant for pre-Columbian times, for colonial times, and even for today. And we can see this in one of the offering pits. There are also green plastic, and in some of these mountain passes there is still green bottles, fragments of green bottles that are offering for protection in the trip. And one thing, and this is just to let this open for the next lecture and for talking, discussing, is that we are wondering if this practice, if these copper minerals that are used in these ritual practices, in these offerings, in this lapidary production, are linked or not with the metal production. Are they sharing the same sphere of circulation, of copper circulation, or did different spheres exist in the past? And we are thinking that this is the second option is the one to choose, but well, let's wait until the next lecture for these results. So vielen Dank. Thank
Thank you very much.
you. You're welcome.
So, well, we can open the discussion for all the people who are remote. Please raise your electronic hand if possible, or type in the chat your question if you like. If we miss you, please just shout.
Yes, it's there.
Any questions or comments?
Yes, Hannah.
Thank you for.
Oh, Hannah, just a second. I should mention that the lecture is being recorded, and also the discussion, so that you know. Sorry.
No problem.
But please, could you speak louder? So.
Okay, you mentioned the caravan of Lama.
Mm-hmm.
Do they pass the Andes, or do they just move to the plains and then descend on the same side again? Do you know that?
Sorry. No, they are going from the desert of Atacama to even the lowlands. They are going through this movement of east to west and west to east. They are doing very long trips. Yes.
Yeah, wonderful talk. Thank you very much, María Florencia. I was, of course, the new source in northern Argentina on turquoise is most interesting. Of course,
Yes.
one would like to know how old it is really in the exploitation. I remember El Salvador in North Chile, and you know the mines that also Valentina was investigating, and González and Westphal, I think, something like that. And I remember that there was a massive in El Salvador, in Las Turquesas, I think the mine was. There was a massive also graveyard nearby, so there was a massive production. Even a mummy was found there, so it is a very famous site. So according to that, I would say what we know from the Atacama is a massive production in the late intermediate period and the Inca period. So it is. You raised the question, is there copper production, arsenical copper, what we know, besides the turquoise and sodalite and whatever production? And I would say, yeah, it seems so, and it's difficult tradition, isn't it? Technical traditions also. Because in the Atacama, it's not really, it's not the same people, not the same communities doing that. And in El Salvador, remember, there's a graveyard, there's really a large community there, somehow related with the turquoise mining. So it seems to be this is different traditions in a way. And also what you have shown with your ritual sites on the passes to the Puna, it shows a bit that there's a special group of people being involved to that.
Yes.
Yeah.
Is
the impression right, or is that?
No, it is. It's About your question about chronology, the team of Gabriel Lopez in Cuenca Viejo, that's the site, and it was very impressive for all of us because we were repeating, okay, in the northwest of Argentina there is no turquoise, and there was, and they have different chronology. They are thinking that the main activity was linked to Inca and just before that, but they have a 700 or 880 datation. And to the other part of the question, yes, the caravan herders are specialized. They are bringing these minerals, but there are also this idea of that it has, well, it's not my idea, it's Axel Nielsen and all the people who are working with this caravan trade, that these are people that are specialized, that they are part of these local communities, but they go, and that's why in this funerary context you can find maybe this like half of the, like a pumpkin with the green mineral around it there, or these wooden tarabitas that are the ones that goes here for the caravans. So they are linked to the local populations, but they go in these long trips. But in this case of the Puna of Jujuy, it seems that these offering pits in these particular mountain hills are local. These are not related to. Of course, these people were related to this caravan trade, but this seems to be a local ritual because of where are these hills, and they are very close to these settlements, and but of course they are accessing to these non-local minerals, so it's all related. So I don't know if I have answered.
Yes, of course, because of course the metal itself, you raised the question with the copper alloys and so might go to a complete different section of society. Yeah?
Exactly.
Yeah, and of course then these beads are special, and this would fit to the local idea and results you have. Yeah.
Yes, yes, exactly.
I think there's a question in the chat as well.
There's a question here in the chat. Sorry. Great presentation. Possible to characterize mineral artifacts using only one of the methods or all the three? No, they are not mandatory, but we prefer at least to have some sample that combines at least two of the methods, because sometimes, for me, it's very important to have first elemental composition, because that gives you the idea of what elements are and makes the identification more accurate. But it is possible with one method, yes, but it's always better to have at least one sample or one group of samples that are with two or three to make the identification more accurate. So, yes?
Have there been any investigations on archaeological links to see what copper minerals could mean? It could, for example, symbolize water or something.
Well, there have been a lot of ethnographical observation about the importance of the hills and the minerals, and there are some studies that, well, it's like it seems that the copper joins very different meanings depending on the context, but there's a research with this Valentina and Francisca Gili that they are talking more about this green as fertility and part of these pastoral rituals for growing the llamas, and in some cases, well, it has to do with this identification of like the caravan herders. So it's a very, it has very different meanings, but they are very linked to each other as green and the rich thing and also this protection, also for asking, but also this shield and protective action. So, yes, there's a lot written about in the Andes. Yes. Yes.
Thank you very much, first of all. It was really, really interesting. And I have a question about the beads again.
Yes.
So if I understood correctly, you say that they were produced elsewhere and brought to the offering pits as ready beads. But at the beginning, you also showed these little fragments where you said that they look like residue of production. So you think they broke the beads down? Because you already also mentioned that they don't fit together.
Yes, no, they don't fit together. It's not a context that you would think that they are producing the beads there. But it has to, as I mentioned, Axel Nielsen says the same. In general, in these mounting passes offerings, they are all broken. I don't know why, but they are like some that they found, and in general they are not completed. But it doesn't seem there that a place to manufacture beads, and in the residential sites you always find them completed, or maybe not so complete, but it's not a context of beads production. And in general, it's not common to find in all the northwest of Argentina context of bead production of turquoise. No? You can find of aragonite or other, the volcanic ash, but it's not so common in turquoise. There's only one site that it's a residential site in the Calchaquí Valley that it's linked to this mine that we have been talking about, Cueva Inca Viejo, that I would dare to say, okay, maybe this is a place because it's the only place where you can find like a debris of turquoise this big. So, but this is something very preliminary, but they are not producing there. And in the mine, they have found some beads like preform and doing, but it's not that they are doing it like a big scale. So that's why it's like an incognito where they are producing the beads, or maybe they are doing it in the north of Chile and bringing them like this, but not there. You're welcome. Yes?
It's not really archaeological, but do you know about the Chuquicamata? And my question is, the excavations are going on?
Not the excavations, but yes, the teams in Chile have made a lot of research there. And this is one of the mines that they are considering as potential source for these minerals that are circulating in the north of Chile and maybe here in the northwest of Argentina. But the thing is that with the Chilean mines, it's not so easy with, for example, other techniques that are used for seeing provenance, like lead isotope analysis, because the signature they have, it's very homogeneous. So what they are trying to do, Valentina, Figueroa, and Pia Sapiens, is trying to see the host rock of the turquoise. Sometimes you can see, and so they are trying to make a protocol to, for example, identify from the turquoise from Chuquicamata to El Abra to El Salvador. But while this is an ongoing research they are doing, we have to do the same in the other side of the mountain and see if we can approach to this provenance and see. What they have seen so far, that in this kind of sites, let me see if I can, that they have found these floors covered with copper. It was farther than I supposed. Here, some of these sites, they have macroscopically identified that some of them have the same potential source. They can be, for example, I'm making this up, but just Chuquicamata turquoise, or just El Abra, or just El Salvador. But in some, they can see that this turquoise might come from different. So they are seeing this difference. In some sites, they see an heterogeneity of these copper minerals, and some sites it could be that it's only one. But well, that's something they are working on. They haven't published it yet, but it's very interesting. And we would like to do the same here in this site, but it's just the beginning. Yes.
Thank you very much. You were talking about the use of copper minerals for pigments. And if I remember it right, you showed the blue and the green ones. Was there also a red pigment?
Yes.
Is it also copper?
No. The red one is oxide, iron oxide. Yes, no. And no, sorry for confusion. No, only the green and bluish. Yes, that's iron. And well, there's evidence for a mine that, but we have been there in El Talar, that it's from more than 10,000 years before present. So they have been exploiting the iron oxide for a long time.
Ramon princess, you mean?
Sorry?
San Ramon
Yes,
princess.
exactly.
Because there is a pigment for coloring of glasses, for example, to color the glass in the red color, cuprite was used. It's very tiny
the oxide.
pigments, copper pigments, but I've never heard about the painted pigments in red, so I was
No,
wondering if
no,
it's
no.
something like this.
No, it's not the copper oxide, no.
Okay.
No, sorry for the confusion. Yes, there was.
What were the conclusive criteria for the provenance of the turquoise? Was it the trace elements in the XRF analysis or the infrared spectra? I didn't get.
Well, it was all together. So that's why I had this group of 60 samples that were analyzed almost for all by all these methods. And there are some that can be of the group of turquoise. Some planerite, for example, appear in Rahmen, but well, it's turquoise anyway. But in general, if it didn't have phosphate and for example, as elemental composition, and the infrared was not so clear, of course, this was not turquoise. So we have to have all this, running together. So. Yes?
On that point, we are still at the beginning understanding the trace element pattern, if there even are, with
Yes.
these materials. So it's still, I would say, preliminary to talk about if there is exchange between Atacama, the Puna, or the local sources. So there's still much work, I understand.
No, it's a lot. And for trace element, I have not the source of turquoise, so I have analyzed some of the turquoise from this cueva in Viejo, and one of the turquoise have, for example, silver, but someone has zinc, so they are very different, and they come from the same vein, and it's just a few meters. So chemical analysis is not working. Lead isotope analysis is not working because they are overlapping this mine. So I don't know, maybe strontium isotope as it was done in the US, but it's something that we have to try, and we have to have the money to do that. But we will try to see what. That's why this approach of looking at the host rock, it's a very good one, at least for the moment, just to see. But well, they have the mines in Chile. They have a lot of fieldwork in the mines, so they can know better. We only have the bits. They are very small, and they have like little host rocks, so it's difficult to say. So we are not in the best position to understand the provenance.
Will come.
Yeah, of course. Right. So, thank you so much for those very interesting questions.